Hi, good morning, everybody, and welcome to AGT's Lunch and Learn webinar this morning. Back to the basics, talking about commercial solar energy. We'll go ahead and give everybody a couple of minutes, maybe just 1 or 2 minutes here to filter in. But we appreciate everybody jumping on and joining us today. It seems like everybody has joined. I'm Clint Sockman, Executive Vice President of Advanced Green Technologies. I've been with the Advanced family of companies for just about 20 years now, a little bit over. I started my construction career as a teenager in the roofing industry, working for my family business, and came down to Advanced in 2005 as a project manager and estimator. 2 years later, we started our solar company, which I currently oversee and qualify with my general contractors, roofing contractors, and solar contractors licenses. And we got a lot of great information here today to talk to you about. So we'll go ahead and get started. Tatiana just dropped a note as well, but if you have any questions, please put them in the chat. We'll address them as they come up or aggregate them at the end and have a lot of time, hopefully left over 15 minutes or so at the end of this conversation to field any questions and get any answers you need to you. A little bit about AGT. We started in 2007, like I mentioned. We're the solar energy division of Advanced Roofing and Advanced Air Systems. We've installed over 400 megawatts of solar around the state, primarily concentrated in the Southeast US and Florida specifically. We hold 2 professional engineers. We employ NABCEP certified employees. Quality is really behind everything that we do. And we also kind of walk the walk with our customers. We have solar installed on 6 of our buildings right now. We're actually in design and permitting to put solar on 2 more of our offices in the Miami and Jupiter areas. So we really believe in what we're doing and we know the benefit of it. And we're going to hopefully explain that very well today. A little update on our upcoming webinars. If anybody needs continuing education units, later this month, we're going over rooftop safety on the 20th, April 3rd, roof asset management technology using our advanced access to manage your roofs better. April 17th, top 10 things property managers need to know. When to re-roof, how to re-roof, getting your budgets, managing warranties, a lot of great things. And then 5/8 hurricane season preparedness. It's right around the corner and we'll be here soon enough. So stick around at the end of the presentation. We do have a raffle. These Turkish beach towels are like an Instagram sensation. People love them. And some nice insulated water bottles to go along with your beach trip. Fill them full of water or margaritas, whatever is your flavor. Learning objectives today. We're going to hit on the technology that's out there right now, some basic on the function of solar assets, and then how we're currently deploying them. We're going to talk about legislative changes that have happened since 2022 and how you can utilize those to get tax credits and additional incentives. We're going to talk and focus a lot on our utility changes. There's been some really big changes to not only your rates, but also how we're going to be able to put solar into the grid and utilize it on your properties. To tech terminology, sorry about that. We're going to talk about billings and understanding what that is and how your bills are structured and how solar can help offset your costs and then any challenges as well. So real quick, high level introduction to solar photovoltaics. Really 2 different types of systems being installed out there right now. Our typical grid-tied systems, which is 95% of what we do, and then hybrid systems where we're creating microgrids using batteries and generators. In a typical grid-tied system, we're harnessing solar energy on a rooftop. That is DC energy, much like a battery. That energy is converted through our inverters, tied directly into your business and utilized by the business rather than taking energy from the utility grid. Now, with our current net metering situation in Florida, we are able to, in the event that we're producing excess during that solar window, actually send that energy back out through the meter and into the utility grid, and then pull it back off when you need it at night. So we're able to use the grid kind of as a storage device. A lot of markets don't have the ability to net meter. It is a big benefit that we have with our investor-owned utilities and publicly regulated utilities in the state. So we love to use that. Matt's going to talk about net metering and what that is a little bit later. Now, for some situations where we have limited export, and these come into play in places like Jacksonville Electric, where they've eliminated their net metering laws. They don't allow you to send the energy to the grid and then get it back for free. We can store energy through our batteries. So we produce a lot of energy during that solar window, which is 6 to 8 hours in the middle of the day. We're able to store it onto batteries and then dispatch it when the building needs it at night, essentially actually using batteries as the storage mechanism instead of that utility grid for free. We're also able to do a lot of interesting concepts around peak shaving and demand side management. We can integrate this in with a generator to make that generator run less and save diesel fuel in the event of a true outage. They can be truly off grid. So batteries are out there. And as battery costs come down, Matt's going to touch on this, we expect battery adoption to really increase. So a lot of good things happening there. Very high level on solar formats and how we're putting solar into the marketplace. I mentioned we're a part of a bigger organization, Advanced Roofing and Advanced Air Systems. Roofing is very much in our heritage. Top left is a 1.5 megawatt solar array for a parts distributor in Miami. And putting solar on rooftops remains the largest portion of what we do, very closely followed by solar carports, both ground-mounted solar carports inside surface parking lots, but then also on parking garages, like bottom left, which is JP Morgan's parking garage. We put an elevated structure above the third floor of their parking garage. Ground-mounted solar, very much like solar farms that everybody is accustomed to seeing the utilities doing thousands of acre farms all throughout the central portions of the state. We're also doing commercial and industrial scaled solar farms on places like landfills or unused green space. Photovoltaics, a little play on words there, but floating solar is out there. It's coming to America and getting a little more adoption. It's limited in its use case, retention ponds, man-made ponds, etc. But it does have a great use case where you have availability of these bodies of water, not using a valuable ground real estate, or in the event that maybe your roof isn't usable. And then the bottom examples along the center and the right side of the screen are what we call architectural solar offerings. So we have solar trees. We actually have solar flowers that wake up every morning and bloom and track the sun. And these are ways that companies are, bringing solar to ground level, expressing that, they care, they're architecturally pleasing, they look good to the eye. And we also have the ability to bring architectural solar to our carports as well, kind of bringing it out of the industrial look and making it more architectural with paint finishes, trims, logos, and branding, etc. So solar incentives in 2025. The biggest portion of the incentive base right now is our 30% tax credit, and that's 30 cents on the dollar for every dollar that is spent. The federal government allows you to take a 30% tax credit. Now, the Inflation Reduction Act, which rolled out in 2022 and has been getting clarity from the Treasury for the last 2 years on how it rolls out, gives us multiple pathways to get additional tax credits. One of those that's the easiest to qualify for is the 10% bonus credit for domestic content. If we're able to prove that certain portions of the manufactured goods inside the solar asset, the racking, the solar panels, the inverters, etc., are made by U.S. manufacturing facilities, we can actually increase that tax credit from 30 to 40%. And we see a use case here for a lot of our rooftops to be able to do that with minimal price increase to the base cost and getting an additional 10% tax credit being a net positive to the financial model. Some of the other more obscure credits that are out there that can be added to this 30% base credit and 10% adders are the 10% bonus for an energy community. This is a community that had a certain amount of its jobs based on mining for fossil fuels or based on fossil fuel power plant usage. Also, the 10 to 20% bonus for qualified low-income housing projects. If you're building solar assets on these low-income communities and housing areas. Now, there's no dollar limit on these incentives. So $100,000 solar array, 30% tax credit, $30,000 credit. $5 million solar array, 30% tax credit, $1.5 million. And that is not limited. It is only limited to really the tax appetite that you have as a business owner, right? And now the tax credits do not have to be taken entirely in year one. They can be carried forward. But that is something that we would need to understand when we are modeling the system. The tax credit is now transferable to third parties. It can be sold. And then one thing that is and maybe one of the biggest things that we see now is this tax credit, which used to only be available to tax paying private companies or publicly traded companies that are paying taxes. This is now available under what they call the direct pay provision of the Inflation Reduction Act to government entities. That could be local, municipal, state, federal agencies, also higher education, so school districts, colleges, and a lot of other nonprofits. The second largest piece of the financial incentive that is out there is the modified accelerated depreciation. Now, in 2025, we're actually able to depreciate the asset 40% in the first year, and then the remaining 60% over the next 4 years. And next year, it is winding down. The bonus depreciation is 20% in year one, the remaining 80% over that 5 year schedule. Now, one quick note, depreciation is only available to tax-paying entities. So while we can get the tax credit as a cash grant under the direct pay provision, depreciation is not a thing that's available to those nonprofit entities that qualify. Now, we already talked briefly on net metering at the state level. Net metering is important. And again, this is the concept of us being able to produce 100% of your building's needs during that solar window, sending out 50 or 60% or whatever it is that's not needed, and then pulling it off the grid at night when it is. And without that, we essentially don't have that grid as a free battery available for us, and we're limited to only being able to produce what we can use at the time when it's produced or using batteries to store it. Some other great things, we do have both sales tax exemptions on solar equipment and property tax exemptions on solar assets. So, when we go out and buy all of these materials, we're not paying any sales tax. That's not being passed along to you. And similarly, when you install these improvements on your property, you're not paying property taxes on that. So those are our state incentives that are available to us here in Florida. The operating expense squeeze, and this is a big squeeze. I'm assuming the majority of the people on this call kind of understand and are probably still feeling the pain of cost increases that have been passed down for various reasons from our utilities, whether it's the rising cost of fuels or the rising cost to maintain the electrical grid because of storm damages and responding to these storms, all valid reasons. But from January of 2022 until December of 2024, the majority of our customers in Florida, regardless of the utility, investor-owned or municipal operated utilities, have seen 30 to 50% increases in their utility bills. And just last week, 2 weeks ago, FP&L has requested another rate increase that was touted as one of the largest rate increases in the history of the United States, $9 billion over 5 years, raising bills anywhere from 14% to residential, and then on an average increase rate of 1 to 5% for our commercial users. And I can't tell you how big this is, but Matt's going to talk about the levelized cost of electricity. And when we invest into a solar asset, we're essentially locking in our price of energy for the 20 years, 25 years of that financial investment. And we're insulating ourselves from these continual price increases and inflationary actions that naturally occur in the market and have really been accelerated in the last 3 to 4 years and continue to accelerate as the cost of doing business gets more expensive for our utilities. Solar is one of the best ways to insulate ourselves from this. So what does a typical payback scenario look like? We like to give everybody these kinds of rules of thumbs. These are guidelines that are loosely equated to our typical projects. Typical project might be 200 kilowatts on a rooftop. or 500 kilowatts to a megawatt on a ground mount. 3 to 5 years for those kind of standard rooftop installations. Our carports with all that additional steel and underground infrastructure for our large scale, 5 to 7 years on a 1 megawatt plus, 8 to 10 years on 300 kW to a megawatt, and then 10 to 12 years and for that lower scaled 100 to 300 kilowatt carport. And again, that's a kind of stack of we get 30% off from our tax credit. We get somewhere between 20 and 30% off from our depreciation. And then we're making up the rest of that with energy savings over that 20-year, 25, sometimes even 30-year period. Matt's made a good point here, and oftentimes we see solar being installed in conjunction with our roofing projects. But in the financial model shown here, the solar actually pays for itself in year 5. And as you continue to save money, it's actually paying for a new roof by year 10. And, when was the last time you got a roof paid for? And a roofing expense is something that a building owner, will often have to, well, always, if the asset's held long enough, take on over the course of the ownership of the asset. And being able to deploy an asset that's saving enough on the operating expense to fund your roof in a few years, pretty interesting concept and something that a lot of our customers take into account. Next slide. One new thing that I'm going to touch on before I pass over to Matt is our drone program. We are running right now about 10 drones around the state, inspecting anything from roof conditions, getting our initial assessments for access points, and making sure we're not missing any details for our layouts, doing moisture surveys and infrareds inspections to see the health of the roof, processing 3D models to get crane locations. But then maybe one of the most important things that we're doing is once an asset is installed, we're able to fly that, establish a record of the health of the system, and then after storms or any maintenance events or things that are happening, confirm that that asset is still producing and healthy. So we're doing a lot with technology right now, and drones are a big piece of that. Time for a quick poll. Are solar investments sales tax exempt in Florida? The poll popped up. I'm going to go ahead and put an answer in here. I think it's not fair that I know it, but we'll wait for the responses to come in. There's 3 of you, 6 of you have responded. Majority of us on the early responders have it right. 89% yes, solar investments are sales tax exempt in Florida. And that's inclusive, guys, of any specific things that are required. So the roof attachments, the copper wiring, the electrical gear, even the steel to build our carports. All fall underneath that. If it is required for the solar installation, then it is sales tax exempt. With that, I'm going to pass this off to Matt Jeffries, Director of Sales and Strategic Accounts with AGT here. Been with me for almost 7 years and is an integral part of keeping our customers happy. He handles some of our most key and strategic accounts and does a great job from sales to ongoing communications and really serving as a single point contact for strategic accounts. He's also apparently king of the ocean. And I think he would like that title probably more than Director of Sales and Strategic Accounts. But Matt, it's all yours.
Awesome. Thank you, Clint. Thanks for everybody for joining us today. I got this email maybe 2 weeks ago, and it really made me think. We prepare these 50-page proposal documents and we send them out, and inside there's all this technical information on production and financial returns and internal rates of return and net present value. And a lot of it's financial, but a lot of it is technical on the solar side. And this client sent back an email saying, I'm not following your lingo. I don't understand all these acronyms. So I thought, in this year's webinar, I'd spend a little bit more time kind of going back to the basics and just talking about how does power work? How is power measured? How are your bills measured? And how does solar impact those bills, right? So we're going to do some pretty basic stuff here. So, The first thing to understand is energy and consumption. So if you think about just a common, 100-watt light bulb, which I guess isn't common anymore. Now that's about 4 watts in the LED world, right? But think about a 100-watt light bulb and you have 10 of those 100-watt light bulbs, you have 1,000 watts or a kilowatt, right? Very basic stuff. 1,000 kilowatts, then, that's a megawatt, or a gigawatt would be 1,000 megawatts. And then you have, this larger term that's used for typically power plants or global consumption, a terawatt, right, which is 1,000 gigawatts. So I just wanted to kind of break this down so it's real simple. Now, if we add the next factor to this, right, so we turn those 10 lamps, light bulbs, whatever, on at 100 watts each or 1 kilowatt for 1 hour, right, and you just multiply those two factors, you now get 1,000 watt hours or 1 kilowatt hour, right? And I know this is really, really basic, but it's important because that is a measurement that's on all of your utility bills, whether they're your residential bills, your commercial bills. It's going to show your consumption in kilowatt hours, just as you see in the bottom right image here of a sample bill. And it's also explaining it just the way I'm explaining it, right? Just a lot of folks don't really take the time to think about it, in these simple, in a simple analogy like this. So, and this client you can see is on a general services non-demand rate structure. And I'll show you what it looks like when we bring demand into it as well. But how solar applies to this type, to consumption in general, right? Doesn't matter what rate structure you're on, but solar can erase consumption because what solar is doing is producing kilowatt hours, right? So if you produce a kilowatt hour with your solar system, you're not purchasing a kilowatt hour from the utility. That's a one-to-one linear correlation or an offset, right? So technically, and I'll show you in an example how you can erase this portion, the consumption portion of this bill with solar. Now, the other thing too is you'll notice on that right-hand side, right down here, there's also a fuel charge that is also tied to the kilowatt hour basis. So not only are you able to eliminate the energy portion of this bill, but you can also eliminate the fuel portion that's also tied, on a kilowatt hour basis. So the next factor we want to talk about is demand, right? So now let's think about this. Let's think about a manufacturing facility, right, or an apartment complex, any type of commercial facility. You don't just have 10 light bulbs and they're not just always on, they're not just always off. Instead, you have complex loads, right, that are switching constantly throughout a given, week, hour, month. So what you end up getting is what you see on the right, and this is actual plotted 15-minute interval data from a manufacturing facility in Miami Gardens. So this is how many kilowatts instantaneously they're taking from the utility over a month's period, right? And you'll see I've got that peak marked at 1150, right? That's the highest point instantaneous. This was when they had the most inrush, the most demand, the one point in the entire month. And that's important because if you look down at the bottom left-hand sample bill, you can see, and this isn't the same bill, but it's representative, they're actually measured and billed based on that peak consumption. And they're charged at, in this case, $11.80 per kilowatt of demand, right? And this is a very common rate structure in Florida, general services with demand for commercial users. I'll show you why this interval data is so important to really understanding how solar could impact this. So now let's look at this demand, the same demand chart, right? And we're just going to pretend a little bit. So on the left-hand side, we're going to pretend that peak occurred at 1:15 p.m., peak solar generating time. And what would happen, the solar is out there, producing power. It's going to clip that demand in that scenario because those two overlap. Now, how far down is it going to clip it? In order to calculate that, we would have to actually have this interval data and then model the production of the solar system based on historical weather data to accurately determine what that impact is. I just theoretically put it to 1,000. It could be 800 or it could be minimal. But that is something that we can calculate with interval data. Now on the right-hand side, let's just pretend that peak was on the same day, but it was at 9:15 p.m., right? So in this scenario, we're not producing, the solar system is not producing. So what impact is it going to have on that demand peak? Zero, right? So that portion of your bill would theoretically be unimpacted. And I'll show you what that looks like. Now, the one thing that this does bring up is, that is the opportunity for battery storage, right? So if you had stored power through the solar system or even from the grid and deployed that power strategically during that peak time, you do have the ability to clip that even during non-solar production times. So, the bottom line is, because this is an instantaneous peak and the timing of when that peak happens is so critical, a solar system by itself alone may not, at all impact this portion of your bill. So let's look at a couple, this is, the software that we use to do these evaluations. If we look at the left-hand side, this was, pre-solar. So this client is on a general services with demand billing structure, just like we looked at on the last slide. So you can see, $15,000 or 54% of their power bill was tied to energy. We can erase that, right? But there's another 13,450, 46% of their bill that's tied to demand. So if you go over to the right-hand side now, you can see, and their savings annually is $20,000. But if you go over to the right-hand side, you can see based on the solar system that we've proposed in this installation, we've completely erased. In fact, they've generated a $1,300 credit for the year on the energy side, but on the demand side, there's still $9,900 in billing remaining, right? So that's the real opportunity for storage. And the one takeaway I would say from this slide is, you need advanced energy and rate structure modeling, and there's software and interval data that are required to really do this. So anytime you're going to get a financial analysis from a solar contractor, if you're on a demand-based rate structure, make sure that they're using that software and that you can get them the interval data that they need to make proper calculations. So here's the dilemma with solar. Some of you have probably heard this term. It's another one that's very common industry lingo that, some people are kind of like, what exactly is it? It's really pretty simple. So it's called the duck curve. And, this is kind of an old slide. I like it just because it has a picture of a duck in it, I guess. But it just shows you what happens over a typical day, especially as solar penetration in a particular market or in a, even on the global scale, starts to increase. So, what happens is as time goes on through the day, your solar production increases, which drags down that demand curve, right? Which is a good thing. But then as the sun starts to go down and those loads are still present, you have this demand peak, right? And that kind of looks like a duck. That's why they call that the duck curve. So this is what a lot of folks have been, struggling with over the last, frankly, 10, 15 years as, solar penetration has happened across the United States. And then you say, okay, well, what are we going to do about it? And what we're going to do about it, and what you're hearing a lot about right now is battery storage, right? So this slide specifically focused on the hardware, the batteries themselves. And you can see several different form factors, different sizes, on the top left-hand side, you've got, a Tesla Powerwall, something that you might see in a residential or a light commercial application. There's 3 or 4 different manufacturers that are listed on this page. You've also got, all-in-one and scalable, stackable type solutions that can be deployed all the way up to like a 5 megawatt-hour self-contained, battery energy storage system. That can be, dropped right in place and interconnected to your current electrical service. Now, the one thing that's really, I think, attractive about this battery technology is the fact that the costs are falling. I mean, if you look at the top right chart, this was, we'll call it 2020. They were making projections. The dotted lines are the projected charts or the cost lines that were expected to be followed over the next, 10 years. 20 years. And then, fast forward a couple of years, you can see the solid line, that starting point is where we actually are. So you can see we're following that yellow line, and we're expecting these costs to decrease by, over 50% in the next 10 years. So that's one thing that happens that's very helpful. The other is that this energy density is also increasing, right? So as these technologies advance, we're able to pack more energy into a smaller format, which benefits the model as well. So bottom line is the hardware exists to do whatever you need to do from a commercial perspective with storage today. Still expensive, but that cost is coming down. Now, Clint talked a little bit about net metering versus net billing. If you were on our webinar last year, we focused on this as well then. The big difference, and you can read kind of through how this works, but to Clint's point, if you can spin your meter in reverse and just generate a negative credit, a negative number, right? Negative 1 kilowatt hours, 2 kilowatt hours, 1,000 kilowatt hours, and then come back when you need those at night or even in another month and access those and spin them back from -5 to 0 to whatever, that's a big benefit, right? In comparison to a net billing environment where think about it as 2 meters. You have 1 meter that says how much power did I take through that meter, and I'm going to pay the full price for it at night, right? And the other meter measures how much power I'm sending out in excess during the day, and I'm getting a credit for it, but that's typically a credit that is at the utility's wholesale cost of power, so 3 to 4 cents, right? So that changes the financial dynamics radically. And a case study has happened. It almost happened in Florida. It's already happening or happened in California with this what they call NEM 3.0 or net energy metering 3.0. It literally stopped, grinded the solar industry to a screeching halt in California in a short amount of time. And if you remember thinking back, a couple of years to that House Bill 741 that made it through the House and the Senate and then went to DeSantis's desk and he vetoed it. If he hadn't vetoed that bill, we would be, Florida would be that case study, not California. So it's pretty dynamic change when you're talking about migrating from net metering to net billing. And we're seeing utilities in the state of Florida, OUC was the most recent, to move over to a net billing structure. So that could be coming. So if it is coming, right, what happens? Well, in addition to benefiting the duck curve or cleaning up the duck curve, battery storage can also be deployed with, very significant software and controls to do what's called energy arbitrage, right? So now we can store that energy when it makes the most sense and then deploy that energy at very strategic times to cut that demand. We're lucky in Florida right now because we have these very simple rate structures like the general services that I showed you or the general services with demand. Our cost structures on those are very, very basic and simple. If you look at California, this chart on the top right, this is a structure in California. So you can see like April 12th at, or let's say March 12th at, you're looking at like a 13, 14 cent export rate, right? I'm sorry, not 13, 14 cents, 1.3 cents, 1.7 cents for that exported power. Then in August, you could get 8 to 9 cents for that power. So with the software, you can strategically store that power and deploy it during peak times. So it's encouraging to know that even if we do migrate to net billing, there's proven hardware and software technology out there that's being utilized to work through it and maintain solar viability. Now, the next term that you hear a lot of times and people say, what exactly does that mean is levelized cost of energy or LCOE. So on the top left, this is again in our standard financial analysis, it'll show you, hey, what's my levelized cost of energy for this PV production versus what's my blended cost that I'm currently paying from the utility. It's a pretty standard model. So in this scenario, you're generating that power for 2.7 cents. You would have otherwise been purchasing it for 16.8. That delta between those two numbers is the whole basis behind the financial model. And the calculation is just as simple as my calculation on consumption, right? It's the total project costs plus any operating and maintenance costs over the life cycle of that asset, the solar asset. So you're basically adding up all of your costs and then you're dividing it by your cumulative production over that term. So you can look at this at a couple different points. Some folks say, hey, I want to know what my levelized cost of energy is during the 25-year warranty period, right? Other folks say, hey, the expected useful life is 30 years, so we're going to divide that out by 30 years. The term can be changed, but that's how the calculation is done, and that's how it really impacts the financial model. Time for a poll here, and another poll. If you turned on this, I mean, this one a little bit difficult, I think, but if you turned on 20 100-watt light bulbs or lamps and left them on for 2 hours, how much energy consumption would flow through your meter? Man, I didn't make it that hard, I guess. That was easier than it's solar non-taxable in the state of Florida. I guess I did a pretty good job of explaining third grade math, right, Clint? But yeah, so the response was 69% in favor of 4 kilowatt hours. It's a simple, multiplication problem. So I guess I didn't expect it to be that hard, but good to go on that one. And closing out with our poll, with the raffle. If you scan this QR code on your screen, it'll take you to where you can register, and we'll notify you if you're the lucky winner of the set of towels or the tumbler. And just to remind everybody, March 20th, rooftop safety. You can scan to register on the right for any of these upcoming webinars. We have roof asset management technology, and we'll go through advanced access, the tool that we use to manage multiple assets within a portfolio. Rooftop assets. On the 17th of April, we're going through the 10 top things that property managers need to know, and then 5/8, just in time for hurricane season, we'll do a hurricane preparedness webinar. And with that, got plenty of time here to open it up for Q&A. Happy to take any questions that you guys might have.
Joan had asked the stability of solar panels on roofs during a hurricane, which is a good question, always a concern. So we install these solar assets, and these assets are designed to the same building code that our roofs are designed to in Florida. So we follow ASCE 7, which is the American Society of Civil Engineers, and they set the standards for wind design in really the entire United States. So anything installed in South Florida, for instance, is designed to 180-mile-an-hour winds. And as we move further up the coast and to the west, those come down up into the Panhandle and Jacksonville, where we might be designing to 130 or 140 miles an hour. Now, they're engineered in a couple of different ways, either using a wind tunnel for some of our proprietary manufacturers who have their own engineering model and wind tunneling models that are in compliance with that code, or using components and cladding, meaning we're actually just engineering the bolts and the connections to withstand the loads that are imposed by these winds. And that's really the attachment methods of how we're attaching to our carports or to our rooftop. Now, the solar panels themselves all come with different ratings, and some of the large panels that are used on utility scale assets wouldn't work on our roofs, and we go to smaller frames that have higher strength ratings. But we have a great track record of success over the last 20 years of putting down solar assets with very high survivability ratings, more north of 99%. We took several direct hits from Hurricane Ian in the last couple of years in the Fort Myers area, and our installations performed extremely well. A lot of our designs for some of our bigger customers are reviewed and approved by Factory Mutual. Factory Mutual, for those of you who don't know, FM Global, really kind of the world leader in underwriting risk assets and insurance policies for the majority of the Fortune 500. And we have solar assets on corporate training facility for KPMG, for instance, in Central Florida. It was reviewed and approved by FM Global. A lot of our installations are FM Global approved, and they're extremely stringent on their requirements for our design. So Yeah, we have the 100% confidence in our designs. They're designed and built to the specific codes. It's not like we're using construction methods for the central part of the U.S. in our high velocity hurricane zone. So, yeah, other than that, I don't see a lot of
Clint,
questions. Here's a couple coming. Aubrey says, have you done solar over open tanks or on tank roofs? We're actually doing, literally doing as we speak, an installation for the city of Boca Raton over a chlorine holding tank. It's an active chlorine holding tank at a wastewater facility. It's being done as we speak. The guys are actually installing the solar. Summit House Management has said, can you go back one slide? I think Matt can do that for you. You gotta get to those QR codes faster, or Matt's a little uh, finger happy here on pressing the mouse cursor. So, yep. Aubrey, that sounds like a pretty specific question. If you have something you want us to take a look at, yes, we can do a lot over open tanks and spanning quite a bit of span. Actually, a lot of our carports span 30 to 40 feet in one direction and up to 60 feet in the other direction. So we can engineer structures to span just about any opening that's out there.
hey, Clint, one of the questions that we get often that we didn't touch on was, what do we need to get started? What do how much information do we need to round up for you? So that's one thing that we usually talk about and we didn't this year. But really all we're looking for to do a high level analysis for you, and this can even be on a phone call. I mean, you could call me today. I would need an address, 12 months of power bills ideally, or at least an idea if we're just trying to do some high level scratch pad math on what your consumption looks like for a calendar year, and your roof condition. If we're looking at rooftop solar, we obviously want the assets, the roof and the solar assets to have a warranty that aligns. So we usually are going to ask those three questions, and in 20 minutes, 30 minutes on a phone call, we can kind of figure out in generalities what your financial returns are going to look like.
It's a good point. To get started, we don't need a lot to do high level assessments. So very good point. There might be one more question. They're filtering in. What is the structure made of over the tank? Steel. It can also be done with aluminum, but this is done with steel and special finishes to allow that steel to perform. So it's a steel structure. We do a lot of aluminum structures as well, but you're limited on the spans at that point. Um, for manufacturers, this has come from Southwest Regional Manufacturers Association. For manufacturers, do you find most are able to use solar to completely run their production facility, or is there a percentage of energy usage used by the solar and a percentage by electricity? We very rarely get to 100% offset on large manufacturing facilities. Typically, it's space constraint, or at our largest types of installations, they're restrained by the regulations in Florida. So we didn't talk about this, but in Florida, with our publicly regulated utilities, so TECO, Duke, Florida Power and Light, we have a 2 megawatt cap. Now that cap is AC, and they apply multipliers, so that ends up being about 2.3 megawatts DC. It's a very large solar array. That's going to put off, in the ballpark of 3.8 million kilowatt hours a year. Roughly. So it's huge. And we've done several installations. We actually did a manufacturer in just north of Tampa. I'm drawing a blank on it. It'll come up, but the name is Barrett, and they go by Alumiguard into the market. They manufacture aluminum powder coated fences for almost every Home Depot, Lowe's around the U.S. Out of this facility, they actually manufacture wooden fences in Canada. They're an enormous company, had enormous power loads. They're extruding aluminum, welding fences, powder coating those fences with ovens that require extremely, high power demands. I would love to pull up an aerial image of Alumiguard. It's 2.3 megawatts on an enormous building. We only clipped about 80% of their energy. Don't forget, we go back to that Matt slide where he talked about the difference between demand and energy. We offset 80% of their energy demand for this huge 150,000 square foot building. And we only offset about 20% of their demand, which are those peaks that we talked about, right? Still a very favorable financial model, producing an enormous amount of power at 2.3 megawatts, extremely successful project. That's just one example, though, and it's a complex answer. Nothing can really be one size fits all. You could have a very small building that doesn't have a lot of room for solar with an enormous demand of, computer processors or cooling or, ovens that require a lot of heat. And maybe we could only get 10% offset. You could have a large building with a minimal demand that's just running assembly lines that I could probably get 100% of your demand, your energy consumption easily. So that's a LumaGuard. Can you roll the timeline forward? There you go. Boom. Those are all solar panels. It's hard to tell how big this is. And actually, it's not hard to tell how big this is. Those are cars that look like ants. And those are solar panels. So this is one of the biggest installations that you can do by regulation in the state. And again, we're actually powering not only that main building, there's a building just to the south in this image. It's a storage head, and we're actually sending, we dug up the parking lot and put in electrical infrastructure to send power to that south building as well. And again, about 80% of the requirements there. And when I tell you this place is unbelievable, I mean it's a giant manufacturing facility of aluminum fencing where they not only finish them and fabricate them and extrude them. It's really cool operation. One of my favorite parts of this business is getting to be so intimate with other people's businesses. And so, yeah, we can do it. Just depends on what it is. Andrea Cookhorn says, what is the average commercial job size? What job size is considered too small? Are there instances that they're not worth the investment for the client? Typically, to answer your last portion of that, no. The returns certainly get frothier as we get bigger, but what I can tell you this is too, our bigger consumers pay less than our smaller consumers. So, and what do I mean by that? If you're a small consumer, you may be under a general services rate. A general services rate isn't demand based; it's all energy based, which is really good for solar, and it's more expensive. We can, if you roll back to that conversation we had about demand and energy, we can offset energy 1 to 1, all of it. We can't offset demand. So when demand is extracted from a rate, those get good returns. A large national storage outfit is one of our biggest customers corporately. Building a couple hundred sites for them right now. And they have some small storage sites that are 60 to 80 kilowatts, and they have good returns and still make the investment metrics. And, that's fine. Now, as I get bigger solar arrays like LumaGuard, my price to install it comes down, but actually they're on what we call like a large user demand-based rate. Those rates are pretty low energy rates, kind of high on the demand side. And so that model changes. Now, for our company in particular, we don't dip below really 50 kilowatts in today's world. And, even at that scale, one-off jobs are less attractive, but we're really focused in the commercial industrial range. I would say our typical commercial jobs, 100 to 150 kilowatts, is kind of typical. Again, 50 to 100 we'll look at on a case by case basis. And as we get below 50, you get geared towards maybe smaller contractors or contractors who are dual focused on residential and small commercial installations. Is the presentation and recording available? Yes, it is. And we do typically distribute this. It'll be on our YouTube channel. It'll be on our website as well. You can access any of this stuff. All right. If nobody has anything else, again, thanks you. Thank you. Have a good day, and I'll give you 10 minutes of your day back. Thanks for attending.
Thank you.